Our solar system is a treasure chest of unsolved puzzles. You are about to discover 25 of its most baffling secrets, from a strange signal that screamed from the void just once to a giant hexagon spinning at Saturn's North Pole. By the end of this journey, you will know the most compelling cosmic mysteries that scientists are still struggling to explain today. We will investigate a planet tilted completely on its side and ask what force could have delivered such a colossal blow. We will probe the ancient evidence that suggests our young, faint sun should have frozen Earth solid, yet somehow our world was covered in liquid water. What does our own cosmic backyard reveal when we look a little closer? That single, powerful signal from the void arrived without warning. In the quiet of an Ohio summer night in 1977, a radio telescope known as the Big Ear was methodically scanning the sky. Its target was the constellation Sagittarius, a dense star field towards the center of our galaxy. Suddenly, a needle on the chart recorder jumped, recording a signal so intense and so perfectly crafted that it defied any natural explanation the astronomers had ever seen. It lasted for exactly 72 seconds, the precise time it took for the telescope's fixed focus to pass over that particular point in the cosmos. The signal was so extraordinary that when a volunteer, Jerry Amon, reviewed the data printout days later, he simply circled the string of letters and numbers and wrote one word in the margin: "Wow." That single word gave the mystery its name. The signal was not just strong, it was also brilliant in its design. It was broadcast on a frequency of 1420 MHz, a radio channel known as the hydrogen line. This is the natural vibration of the most common element in the universe, and many scientists had long proposed it as the logical, quiet channel for interstellar communication, a cosmic hailing frequency. The wow signal was not random noise. It was a deliberate, narrow-band transmission, a clean, pure tone that screamed intelligence. Yet after that one perfect burst, the signal vanished. It has never been heard again. For decades, astronomers have pointed every available instrument back towards that same spot, listening with ever more sensitive equipment. They have heard only the usual cosmic static. This profound silence is what fuels the greatest debate. What could have produced such a powerful, targeted, and intelligent signal, only to disappear forever? Was it a one-time event, a natural cosmic catastrophe we simply cannot explain? Or was it a fleeting message, a hello from a distant civilization that we were just a moment too late to answer? The wow signal remains the most tantalizing, frustrating, and enduring mystery in the search for cosmic company, a ghost in the machine of the universe that continues to whisper, "What if?" That ghostly signal from the cosmos is not our only encounter with the illusion of intelligence. Just 1 year before the Big Ear heard its mysterious whisper, another human eye was staring into the void, this time aimed at our rust-colored neighbor, Mars. The Viking 1 orbiter was mapping the Martian surface when it captured an image of the Cydonia region that would ignite imaginations worldwide. There, etched into the alien landscape, was what appeared to be a colossal human face, staring blankly up at the sky. It was over a mile across, with seemingly perfect symmetrical eyes, a nose, and a mouth. The public went wild. Was this a monument, a relic of a long-lost Martian civilization, built to signal its existence to the stars? The idea was intoxicating, a story written in the very geology of another world. Decades of speculation followed, fueled by our deep-seated desire to find meaning and company in the cosmos. Then the cold, clear light of better data arrived. The Mars Global Surveyor spacecraft revisited Cydonia in the late 1990s and early 2000s, armed with far superior cameras. The new images revealed the truth. The face was gone. In its place was a very large, very ordinary-looking mesa, a flat-topped hill riddled with rocks and sand dunes. The striking facial features were nothing more than a trick of the light and shadow, an illusion created by the low resolution of the original Viking photograph and the specific angle of the sun. This psychological phenomenon, where our brains perceive familiar patterns like faces in random shapes, is called pareidolia. We see the man in the moon, the virgin in a grilled cheese sandwich, and for a time, a monument on Mars. Yet, even with the mystery solved, a subtle question lingers. Why is that particular mesa so unusually symmetrical? The collapse of the face theory does not fully explain the underlying geology that made the illusion so powerful in the first place. The forces of wind and time that carved this formation created a strangely balanced shape, a natural coincidence so perfect it fooled an entire planet. It serves as a profound lesson, a reminder of how desperately we want to find ourselves reflected in the universe, and how carefully we must look to separate our hopes from the hard, often stranger, truth of reality. Our search for signs of life took a more scientific turn with a discovery right under the noses of our Martian rovers. The Curiosity rover, crawling through Gale Crater, has repeatedly sniffed out a tantalizing gas in the thin Martian air, methane. This is far more than a simple geological curiosity, because on Earth, the vast majority of methane in our atmosphere is produced by living organisms, from microbes to cows. Finding it on Mars immediately raises the electrifying possibility that we are detecting the breath of Martian microbes, life hidden deep beneath the rusted soil. The plot, however, thickens considerably. While some geological processes can produce methane through a reaction between water, carbon dioxide, and certain rocks known as serpentinization, the behavior of the Martian methane defies easy explanation. It does not just linger at a constant, low level as a steady geological process might suggest. Instead, it behaves erratically. The Curiosity rover has recorded a background level that rises and falls with the Martian seasons, and even more puzzlingly, it has occasionally detected sudden, intense spikes where the methane concentration skyrockets tenfold before vanishing almost as quickly as it appeared. These dramatic plumes are like cosmic ghost stories, appearing and then dissolving into nothing. The European Space Agency's Trace Gas Orbiter, specifically designed to study this very mystery, has added another layer of confusion. From its high orbit, it has often failed to detect these same methane spikes that the rover on the ground is measuring. This contradiction deepens the enigma. Is the methane incredibly localized, seeping out from specific, isolated vents, and then being destroyed by some unknown process before it can spread high into the atmosphere? Or is there some strange chemistry happening at the surface that we do not yet understand, a process that creates the gas and then destroys it in an instant? The Martian methane is a riddle wrapped in a mystery. Its fleeting, unpredictable nature challenges everything we think we know about both geology and biology, leaving us with a profound and unresolved question. Is the red planet whispering a secret of life, Or is it simply performing a chemical magic trick we have yet to decipher? While the Martian methane teases us with the possibility of life, another world in our solar system presents a geometric puzzle of staggering precision. High above the swirling clouds of Saturn, a perfect hexagon encircles the planet's north pole. This is not a fleeting cloud formation, but a permanent, towering structure of storms, a six-sided jet stream that has remained locked in place for decades, perhaps even centuries. Each of its sides is longer than the entire diameter of our own planet Earth, making it one of the largest and most defined weather patterns ever witnessed. The first human eyes to see it belonged to the Voyager probes in the early 1980s, but it was the Cassini mission that revealed its full, breathtaking complexity. How does such a perfect geometric shape form and persist in the turbulent, chaotic atmosphere of a gas giant? The dominant theory points to fluid dynamics, suggesting it is a massive, stable standing wave. You can create a simpler version of this in your own kitchen by spinning a bucket of water. As the fluid rotates, smaller, geometric shapes can briefly appear in the flow. On Saturn, the planet's rapid rotation, combined with differences in wind speed at various latitudes, might be generating this colossal, six-sided wave. Yet this explanation hits a wall. Laboratory experiments and computer models can create similar polygonal shapes, but they are always transient, flickering in and out of existence. None can replicate the unwavering stability and the razor-sharp, 60-degree angles of Saturn's hexagon. It has outlasted every storm and season Cassini observed, an unyielding geometric sentinel. This suggests that something fundamental is missing from our understanding of planetary weather systems. What hidden property of Saturn's deep atmosphere, what combination of wind shear and internal heat, could possibly lock a storm of this unimaginable scale into a shape so perfect it looks engineered? The hexagon stands as a monumental question mark, a natural phenomenon that defies the very nature of nature's chaos. While Saturn displays a storm of perfect geometry, its colossal neighbor Jupiter roars with a vortex of pure, untamed chaos. This is the Great Red Spot, a storm so vast that our entire planet Earth could be swallowed within its crimson winds 2 or 3 times over. We have watched this titanic anticyclone for more than 350 years, with human eyes and telescopes tracking its slow, relentless churn since the 17th century. It is a hurricane that has lasted for centuries, a tempest that makes every storm in human history seem like a fleeting whisper. The fundamental mystery is not just its size, but its endurance. What unimaginable source of energy could possibly power such a persistent, furious whirlwind? On Earth, even the most powerful hurricanes are born over warm ocean water and quickly die when they move over land or cooler seas. Jupiter has no land, no solid surface to disrupt the flow. The Great Red Spot is a self-sustaining engine, feeding on the smaller storms and the sheer thermal energy rising from the gas giant's incredibly hot interior. It is a storm that literally eats its competition, absorbing smaller vortices to maintain its own monstrous life. Yet, even this ancient behemoth is changing. Recent observations reveal it is shrinking. For centuries, it was wide enough to fit 3 Earths side by side, but now it is barely large enough for one. At the same time, its iconic brick red color has been deepening, shifting to a more intense, rich ochre. No one is sure what these transformations mean. Is the storm finally, after centuries, showing signs of old age? Or is this simply another phase in a life cycle we cannot possibly comprehend? The greatest enigma lies beneath the cloud tops we can see. Our probes can only observe the outermost layers of this churning maelstrom. What is happening deep below, in the abyssal layers of the atmosphere, where pressures are thousands of times greater than on Earth? Does the storm have deep, rotating roots that anchor it to Jupiter's interior, or is it a relatively shallow atmospheric feature? We simply do not know. The Great Red Spot is a monumental clockwork, a celestial machine whose inner workings remain hidden, leaving us to wonder how much longer this legendary storm can defy the tides of time and physics itself. Deep within the remote Siberian wilderness, a cosmic mystery unfolded with the force of 1,000 suns. On the morning of June 30th, 1908, a colossal fireball tore across the sky over the Tunguska River. Moments later, the ground shook with the violence of a magnitude 5.0 earthquake as a blast of heat and pressure, hundreds of times more powerful than the atomic bomb dropped on Hiroshima, ripped through the atmosphere. It flattened an estimated 80 million trees across 2,000 square kilometers of forest, scorching the land and leaving the trees felled in a bizarre radial pattern, all pointing away from the epicenter. Eyewitnesses dozens of kilometers away were thrown from their feet by the shockwave, their clothes nearly set on fire by the searing heat. Yet, when scientists finally reached the remote site 19 years later, they found a scene of utter devastation with a profound absence at its heart. There was no crater. The ground zero showed no sign of a massive impactor, no buried asteroid, no fragments of a rocky visitor from space. This absence is the core of the Tunguska enigma. What could deliver such an unimaginable punch without leaving a single, definitive piece of itself behind? The leading theory points to a stony asteroid or a fragile comet nucleus, perhaps 50 to 60 meters wide, that never actually struck the Earth. Instead, it is believed the object entered our atmosphere at a shallow angle and tremendous speed, superheating the air around it until the stresses became too great. The entire body then disintegrated in a massive airburst, roughly 5 to 10 kilometers above the ground, unleashing its entire kinetic energy in a single, catastrophic flash of heat and a devastating pressure wave that hammered the forest below. This explains the radial tree fall and the complete lack of an impact scar, as the object vaporized itself in midair. Yet, even this compelling explanation is not without its problems. Expeditions to the site have found microscopic globules of rock and metal in the peat and soil, potential remnants of the body, but not enough to definitively identify its composition. The lack of a clear debris field has allowed more exotic ideas to persist, such as the passage of a small, primordial black hole through our planet, though no evidence supports this. Over a century later, the Tunguska event stands as a sobering reminder of our planet's vulnerability. It was a direct hit from a cosmic projectile that, had it arrived just a few hours later, would have annihilated a major European city. The exact nature of the impacting body remains one of the greatest unsolved mysteries in our near-Earth environment, a ghostly impact that challenges our understanding of how the cosmos sometimes chooses to strike. Far beyond the orbit of Neptune, in the deep freeze of our solar system's frontier, lies a ring of frozen relics known as the Kuiper Belt. This is the realm of Pluto and a trillion other icy worlds, the leftover building blocks from the dawn of our planetary system. For decades, astronomers assumed this population of objects would gradually thin out, fading slowly into the emptiness of interstellar space. But the data from our most powerful telescopes has revealed something far more startling and structured. There is a cliff, at a distance of about 50 astronomical units from the Sun, which is 50 times farther than Earth is from the Sun. The number of detectable Kuiper Belt objects plummets. It is not a gentle decline, it is a stark and sudden drop, as if the solar system simply ends at a cosmic boundary wall. This is the Kuiper Belt cliff, and its existence defies our basic expectations. If the solar system formed from a vast, swirling disk of gas and dust, logic dictates that the outer fringes should show a slow, steady decrease in material. This sharp cutoff suggests something powerful happened here, something that either cleared out the region or prevented it from ever being populated in the first place. One of the most compelling and controversial theories points to the gravitational hand of an unseen giant. The hypothetical planet 9, a world possibly 10 times the mass of Earth, is thought by some to orbit far beyond this cliff. Its immense gravity, the theory goes, could have shepherded the distant Kuiper Belt objects into clustered orbits we see today, while simultaneously flinging any objects that ventured too close out into the darkness, creating this artificial-looking edge. Yet this grand idea has a simpler, and in some ways more troubling, rival. Perhaps the primordial disk of material that birthed our planets simply had a very sharp outer edge. Maybe our solar system's original nursery was smaller and more neatly defined than our models predict, ending so abruptly that it left this fossilized boundary frozen in time for billions of years. This alternative challenges our understanding of how star systems are born. What process could carve such a clean edge in a cloud of cosmic dust? The Kuiper Belt cliff stands as a silent sentinel at the border of the known, forcing us to question whether we are being influenced by a hidden neighbor, or if we must fundamentally rethink the very shape of our cosmic cradle. Even the stormy chaos of Jupiter pales before a structure of pure atmospheric elegance found on our closest planetary neighbor. At the scorching south pole of Venus, a colossal and permanent hurricane spins, but this is no ordinary vortex. Seen in stunning detail by the European Space Agency's Venus Express orbiter, it possesses a bizarre double eye, two distinct centers of rotation, tangled together in a vast, swirling dance. This double vortex is not a fleeting event, it is a permanent fixture, a complex atmospheric engine locked above the planet's pole. The sheer persistence of this paired storm defies our basic understanding of fluid dynamics, where such systems typically merge or collapse into a single, stable center. Yet on Venus, the two eyes remain forever entwined. This phenomenon is deeply coupled with one of the planet's other great mysteries, its super-rotating atmosphere. The entire blanket of air on Venus whips around the planet at hurricane speeds, completing a full circuit once every 4 Earth days, while the planet itself takes 243 days to make a single, sluggish rotation. This means the winds are screaming around Venus 60 times faster than the planet spins. The polar vortex is thought to be the planet's way of venting this tremendous atmospheric energy, a massive sinkhole where the fast-moving winds plunge downward in a chaotic yet strangely structured dance. The greatest challenge for scientists is not just observing the vortex, but recreating it. Supercomputers running sophisticated climate models of Venus can produce a polar vortex, but they consistently fail to generate the stable, double-eyed structure we actually see. The simulated vortices are often single-eyed, or they flicker in and out of a double state, unable to lock into that persistent, dynamic pattern. This failure tells us something critical is missing from our equations. What hidden variable in the Venusian atmosphere, what subtle interplay of temperature, chemistry, or topography is required to spin this particular atmospheric knot? The double vortex of Venus is more than just a storm. It is a complex atmospheric fingerprint, a unique signature of a world whose weather operates by rules we are only beginning to decode. Our own moon holds a secret history of flickering lights. For centuries, astronomers using everything from simple telescopes to advanced observatories have reported strange, fleeting events on its surface, brief flashes of light, sudden patches of glowing mist, or areas that temporarily darken for no apparent reason. These are the transient lunar phenomena, or TLP, and they defy our perception of the moon as a dead, unchanging rock. The catalogue of these events is vast and varied. Some observers report pinpoint flashes that last for just a second, while others describe large, hazy regions that glow with a dull red or violet light for hours before fading away. One of the most famous sites for this activity is the crater Aristarchus, a brilliant, deep gouge in the lunar surface that seems to be a particular hotspot for these mysterious glows. The challenge and the source of great scientific debate is that these phenomena are maddeningly unpredictable and brief. One astronomer might see a brilliant flash in a specific crater, but by the time another telescope is pointed at the same spot, the moon has returned to its usual silent self. This elusiveness has led to a fundamental question. Are we witnessing real geological processes, or are these simply tricks of the eye, illusions caused by Earth's turbulent atmosphere distorting the view? The potential explanations for real TLPs are as fascinating as the lights themselves. One leading theory points to outgassing. The moon's interior may still hold trapped radioactive elements that slowly decay, heating the rock and releasing pockets of gas like radon. When this gas seeps out and reaches the sunlit surface, it could stir up the ultra-fine, electrostatically charged lunar dust, making a patch of the surface appear to shimmer or glow momentarily. Another, more violent cause could be meteoroid impacts. The moon has no atmosphere to burn up incoming space rocks, so even a pebble-sized object striking the surface at tens of thousands of miles per hour would release a tremendous flash of light, visible from Earth. There are even more speculative ideas, such as tidal stresses. The gravitational pull of Earth flexes the moon's crust, much like our oceans are pulled by the tides, and this stretching could create electrical charges or open up deep cracks, releasing trapped gases. Yet, for every possible explanation, there is a counter-argument. If outgassing is so common, why do we not detect its chemical signature more consistently? If impacts are the sole cause, the observed frequency and duration of some glows do not always match up. The debate continues because our tools are still imperfect. Modern projects use automated telescopes to constantly monitor the moon, hoping to catch a TLP in the act with multiple instruments simultaneously. Until we can get a definitive measurement, these flickering lights remain one of the oldest and most personal mysteries in astronomy, a ghostly ballet of illumination on our closest celestial neighbor that challenges our very definition of a world that is truly dead. Beyond the Kuiper Belt's sharp edge, lies an even more distant and ghostly realm, a vast spherical shell of frozen objects known as the Oort Cloud. This is the solar system's final frontier, a theoretical reservoir of trillions of icy bodies so far from the Sun that they are barely bound by its gravity. The existence of this cloud explains the origin of long-period comets, those rare visitors that swing into the inner solar system from every conceivable direction. Yet the very formation of this distant halo presents a paradox that strikes at the heart of our solar system's history. How did these objects, which must have formed in the warmer, denser disk near the giant planets like Jupiter and Saturn, end up in this unimaginably distant and sparse cloud? The energy required to fling them outward is titanic, but the physics is unforgiving. Any push powerful enough to send them that far should have been just strong enough to eject them from the solar system entirely, casting them adrift into interstellar space. So why did they stop? What force put the brakes on their cosmic journey, leaving them suspended in this gravitational twilight zone? One compelling theory suggests our Sun was not born in isolation. It was likely formed within a dense cluster of sibling stars, all blazing to life from the same cosmic nursery. In this crowded stellar neighborhood, close flybys from other young stars would have been common. The gravity of a passing star could have acted like a cosmic slingshot, violently perturbing the orbits of these icy planetesimals. Instead of being flung away forever, their outward momentum could have been precisely countered by the star's own gravitational pull, effectively trapping them in the vast spherical shell we infer today. It is a model that requires a dramatic past, a time when our Sun had close stellar companions that have long since drifted away into the galactic void. A competing and perhaps more unsettling idea points to forces within the galaxy itself. As our solar system orbits the center of the Milky Way, it does not move on a perfectly flat plane. It bobs up and down through the dense disk of the galaxy. During these passages, the collective gravity of the galaxy's stars, gas, and dark matter, known as the galactic tide, could have gradually tugged and reshaped the orbits of these scattered objects. This immense but gentle force, acting over billions of years, could have shepherded them into the distant, spherical cloud we now hypothesize. So we are left with two grand possibilities. Was the Oort Cloud sculpted by a brief, violent encounter with a sibling star in our solar system's infancy? Or was it patiently assembled over eons by the imperceptible, galaxy-wide tide? The answer is frozen into the orbits of comets yet to be discovered, a silent record of whether our Sun's birth was a chaotic family affair or a lonely drift through an immense and structured galaxy. That same faint young sun presents us with a profound contradiction written in stone. 3.5 billion years ago, our star was a dimmer, cooler presence, shining with only about 70% of its current warmth. According to every basic law of physics, the early Earth under this pale sun should have been a global snowball, a glittering ball of ice with average temperatures far below freezing. Yet the geological record tells a completely different story. Ancient rocks from that era show clear, undeniable signs of being formed in the presence of liquid water. We find ripple marks preserved in stone, identical to those on a riverbed today, and minerals that can only crystallize in warm, flowing water. The evidence is overwhelming. Our young planet was not an icy wasteland. It was a world of rivers and oceans, a world that was surprisingly, bafflingly warm. This is the faint young sun paradox. a direct conflict between our understanding of stellar evolution and the hard evidence locked in our own planet's crust. How could a freezer have functioned as an incubator? The most popular solution points to a supercharged greenhouse effect. Perhaps the early Earth's atmosphere was much thicker, rich in potent heat-trapping gases like methane, carbon dioxide, and maybe even ammonia. This dense, insulating blanket could have trapped enough of the sun's meager heat to keep the planet comfortably above freezing, creating a planetary sauna. But this elegant idea runs into a major problem when we look next door. Mars shows the very same geological evidence for a warm, wet past, with ancient river deltas and lake beds etched across its surface. If a thick greenhouse atmosphere was the solution for Earth, it should have been even more effective for Mars, which is farther from the Sun. Yet Mars is smaller, with weaker gravity, and could not have held onto such a dense atmosphere for long. It would have been stripped away by the solar wind, leaving the planet to freeze. So how did Mars also stay warm? This dual mystery forces scientists to consider more exotic possibilities. Perhaps Earth's early atmosphere was not just thick, but also hazy, filled with a smog of organic compounds that acted like a sunshade, paradoxically cooling the surface while greenhouse gases did the warming. Or maybe the young planets themselves were darker, with less reflective landmasses and no bright ice caps, allowing them to absorb more of the sun's faint light. Some have even proposed that the fundamental nature of the sun itself was different, with a higher proportion of violent solar flares that heated the planet's upper atmospheres. But no single theory elegantly solves the paradox for both Earth and Mars at the same time. The faint young sun paradox remains a deep, unresolved flaw in the story of our origins, forcing us to question whether we truly understand the delicate balance that makes a world a home. Deep in the silent expanse between the planets, two robotic pioneers were caught in a subtle but relentless tug. The Pioneer 10 and 11 spacecraft, after completing their missions to Jupiter and Saturn, were hurtling outward toward the stars. Yet as scientists tracked their precise trajectories over decades, they noticed something was wrong. Both spacecraft were experiencing a tiny, unexplained deceleration, a constant, sunward pull so faint it was equivalent to just 1/10,000,000th of the gravity we feel on Earth, but it was undeniably there. For years, this pioneer anomaly hinted at a crack in our understanding of physics. Was it evidence of dark matter's gravitational drag? Could it be a sign that Einstein's theory of gravity needed a slight modification at the vast scales of the solar system? The possibility of new physics hung in the air, a tantalizing whisper from the void. The true answer, however, was far closer to home, hidden in the mundane reality of engineering. These spacecraft were powered by the gentle heat of radioactive decay, and that heat had to go somewhere. It was radiated away from the vehicles as infrared light. Every time a photon of heat radiated from the warm side of the spacecraft, it gave a minuscule push, like the subtle recoil from a gun. The primary source of this thermal radiation was the spacecraft's own electrical power generators. But the real key was asymmetry, the fact that more of this heat was radiated from the back of the spacecraft's main antenna dish than from the front. This imbalance created a net force pushing back against the direction of travel, producing the exact, tiny deceleration that had so baffled scientists. It was not a mysterious force from the cosmos, but the collective kick of countless photons of waste heat, a force so small it was only detectable after years of flawless travel across billions of miles. The resolution of the Pioneer anomaly was not a disappointment, but a triumph of meticulousness. It taught us a profound lesson about the demands of interplanetary navigation, where the slightest effect, even the pressure of light itself, must be accounted for. It proved that to explore the furthest reaches of space, we must first master the physics of our own spacecraft, down to the last forgotten photon. Even our most distant emissaries can send back puzzles we never anticipated. When Voyager 1 finally crossed the threshold into interstellar space in 2012, it was a monumental human achievement. The spacecraft had pierced the heliopause, the final boundary where the sun's outward flow of solar wind meets the pressure of the galactic void. Scientists expected a clean break, a moment when the sun's protective bubble would vanish, allowing the full, unfiltered blast of cosmic rays from the galaxy to flood in. These high-energy particles, accelerated by distant supernova and other cosmic cataclysms, should have surged as Voyager left the sun's influence behind. The data, however, told a different and far more confusing story. The intensity of these galactic cosmic rays did not simply jump to a new, high level and hold steady. Instead, it began to fluctuate wildly, rising and falling in unpredictable waves. It was as if the spacecraft had not entered a calm, open sea, but was instead navigating a choppy and turbulent shore, with waves from the ocean crashing back against the river's mouth. This bizarre ebb and flow was completely unexpected, and it pointed to a fundamental flaw in our model of the heliosphere. We had pictured this cosmic bubble as a relatively simple, comet-like shape, streamlined by the sun's motion through the galaxy. Voyager's data suggests a far more complex and dynamic structure. The boundary may not be a single, sharp wall, but a layered and porous region of magnetic froth, a place where the solar and interstellar magnetic fields tangle and reconnect, creating temporary channels and barriers that cosmic rays must navigate. Some theorists now suggest the heliosphere could be shaped less like a comet and more like a quass, with a complex, layered tail that creates these observed ripples and variations. The implications are profound. The heliosphere is our primary shield against the harsh radiation of deep space, and its true shape and behavior directly affect the environment of every planet within it. If its boundary is a chaotic, rippling membrane instead of a stable wall, what does that mean for the long-term safety of future interstellar travelers? The cosmic ray anomaly forces us to redraw the map of our own cosmic neighborhood, revealing that even after crossing the final frontier, the greatest discovery is often how much we still have left to learn. Saturn's moon Iapetus presents a silhouette unlike any other world we know. From certain angles, it looks less like a moon and more like a cosmic walnut, its spherical shape bisected by a colossal, razor-sharp ridge that runs perfectly along its equator. This is not a gentle mountain range. It is a wall of solid ice and rock that soars 20 kilometers into the black sky, taller than Mount Everest by more than double, and it stretches for over 1,300 kilometers, a continuous spine that wraps the entire world. How does a moon grow a feature so bizarrely precise, so perfectly aligned with its equator that it appears almost machined? The leading explanation suggests a dramatic collapse from above. Iapetus may have once possessed its own glorious ring system, a miniature version of its parent planets. Over time, the moon's gravity would have steadily pulled this ring of icy debris downward. Instead of crashing down randomly, the particles, already locked into an equatorial orbit by the Moon's own rotation, would have rained down in a continuous, linear bombardment, piling up along the equator to form this impossible ridge. It is an elegant idea, a fallen ring forever fossilized as a mountain range. Yet, this theory faces a formidable rival from within. Perhaps the ridge was forged by the Moon itself during a more violent youth. If Iapetus spun much faster in its infancy, its rapid rotation could have generated immense internal heat and forces powerful enough to squeeze material upward, bulging at the equator until it froze into this permanent scar. This endogenic, or internally generated, model points to a world that literally shaped itself under the stress of its own motion. There is, however, a third, even more catastrophic possibility. What if a colossal impact early in the solar system's history shattered a proto-Iapetus, sending a cloud of debris into orbit? This debris would have quickly settled into a thin, hot disk of material circling the wounded Moon, a personal accretion disk. Over time, this disk would have rained back down, but only along the equatorial plane, depositing its entire mass in a single, continuous line that became the ridge we see today. Each of these theories has its own critical weakness. A collapsed ring should leave behind a ridge of loose, porous material, but the ridge appears solid and ancient. Internal forces from a fast spin struggle to explain the ridge's incredible sharpness and linear perfection, and a giant impactor would need to strike with near impossible precision to create such a symmetrical debris disk. The equatorial ridge of Iapetus stands as a monument to our uncertainty, a geological question mark carved on a world of ice, challenging us to decipher whether it is the ghost of a ring, the scar of a feverish spin, or the fallout from a primordial collision that shaped a moon into a walnut. While some moons wear their history as frozen ridges, another of Saturn's satellites actively broadcasts its secrets into space. The Cassini spacecraft witnessed an impossible sight at the small, icy moon Enceladus, brilliant plumes of water vapor and ice crystals erupting from its south pole, shooting hundreds of kilometers into the void. These are not random geysers, but a continuous, organized series of jets blasting from 4 massive fissures in the ice, nicknamed the Tiger Stripes for their distinctive appearance. This entire region is unnaturally warm, a localized hotspot in the deep freeze of the outer solar system. The sheer existence of these plumes is a direct challenge to our understanding of celestial mechanics, because Enceladus is a tiny world, just 500 kilometers across. Its small size means it should have cooled and frozen solid into an inert ball of ice billions of years ago. Yet here it is, actively venting its internal ocean into space. The plumes themselves are the key evidence. Cassini flew directly through them, tasting their composition. The analysis revealed they are not just simple water. They contain a fascinating cocktail of salts, silica, nanoparticles, and a variety of organic molecules, including methane, carbon dioxide, and propane. This chemical mix points unequivocally to a global, salty ocean, trapped between the moon's rocky core and its icy shell, and it suggests that this hidden sea is in direct contact with a hot, rocky seabed. This leads to the central energy mystery. What force could possibly be powerful enough to keep this ocean liquid so far from the sun's warmth? The primary suspect is tidal heating. Enceladus orbits Saturn in a slight elliptical or oval-shaped path, and it shares an orbital resonance with the larger moon Dione. This gravitational dance means that as Enceladus moves closer to, and then farther from Saturn, the giant planet's immense gravity relentlessly squeezes and stretches the small moon. This constant flexing generates immense friction and heat within its rocky core, acting like a planetary engine. This heat is enough to maintain the subsurface ocean and melt the ice at the South Pole, creating the pressure that forces the water through the tiger stripe fractures and out into space. The presence of tiny silica grains in the plumes, which can only form in hot water interacting with rock, strongly supports this model of hydrothermal activity on the seafloor. This is where the possibility of life becomes electrifying. On Earth, we find entire ecosystems thriving in the absolute darkness of the deep ocean, clustered around hydrothermal vents. These oases of life draw their energy not from the sun, but from the heat and chemistry of the Earth's interior. The data from Enceladus suggests it possesses all the key ingredients for such life: liquid water, a source of chemical energy, and the essential organic building blocks. The plumes offer us a free sample, a direct taste of that alien ocean, without the need for a difficult landing or drilling through kilometers of ice. This makes Enceladus one of the most compelling targets in the entire solar system in the search for life beyond Earth. Future missions are already being planned, probes designed to fly through the plumes with even more sophisticated instruments, specifically tasked with looking for the complex organic molecules and potential biosignatures that would indicate not just a habitable environment, but an inhabited one. The jets of Enceladus are more than a beautiful spectacle. They are an open invitation, a cosmic message in a bottle telling us that even in the most distant and frozen reaches, the conditions for life can and do arise. Even on a world of ice, the ground can tear itself apart. The moon Teutonia, orbiting the distant, tilted world of Uranus, is scarred by a canyon system so immense it defies belief. Named the Messina Chasmata, this colossal rift is not just a crack in the surface. It is a tectonic wound that dwarfs our own Grand Canyon in scale relative to its world. If a similar feature existed on Earth, it would stretch across entire continents, a chasm so deep and vast it would redefine our very geography. The sheer existence of this feature is the heart of the mystery, because Teutonia is a small, frozen moon. With a diameter of just 1,500 kilometers, it should have lost its internal heat and become a geologically dead, inert ball of rock and ice billions of years ago. A world this small and cold simply lacks the radioactive elements and residual formation heat to power the kind of planet-spanning forces that create such a chasm. So what colossal pressure could have ripped its crust open? The prime suspect is a dramatic event in the moon's deep past, a global expansion. As Teutonia's interior slowly cooled, any subsurface ocean of water and ammonia would have begun to freeze. Water is a unique substance. It expands as it turns to ice. If a global ocean trapped beneath the moon's crust began to solidify, the tremendous pressure from this expansion could have literally stretched the entire world, causing the brittle outer shell to crack and split open along a massive fault line, creating the Messina Chasmata. This theory paints a picture of a moon cracking like an overfilled ice cube in a freezer. Yet, there is a more violent and dynamic possibility. Perhaps Teutonia was not always frozen solid. In its youth, it may have been warm enough for its interior to separate into distinct layers, with a rocky core, a mantle of warm, convecting ice and a solid crust. The gravitational tug of Uranus, and possibly even other moons, could have generated tidal friction, flexing the interior and keeping it active for a time. This internal heat might have driven tectonic forces, pushing and pulling the crust until it ruptured in this single, catastrophic tear. The very presence of the canyon suggests that Titonia's history was not one of quiet, deep freeze, but of a brief, geologically violent epoch. But this leads to an even deeper question. What was the trigger? Was it a slow, inexorable freeze that fractured the moon from within? Or did a sudden, powerful event, like a shift in its orbital resonance with another moon, deliver a final, wrenching blow that tore the crust apart? We have only the silent, frozen evidence to read, a scar on a small world that whispers of a past far more turbulent and active than we ever imagined. Neptune's own moon system holds a ghost from the outer dark, an object that refuses to follow the rules. Nereid, the third largest of Neptune's moons, travels an orbit of such wild extremes it stands alone in the solar system. Its path is a lopsided, stretched ellipse, the most eccentric of any known moon. On its closest approach, it swings to within just over 800,000 kilometers of the cloudy blue giant, only to then be flung outward on a staggering journey that carries it almost 10 million kilometers away, over 10 times farther out. This is not the stately, circular dance of a moon born alongside its planet. This is the frantic, looping trajectory of an object that was captured, a refugee from the frigid Kuiper Belt. The leading theory suggests that in the solar system's violent youth, Neptune's immense gravity reached out and snatched Nereid from that distant population of icy bodies, forcing it into a new, permanent servitude. Yet this elegant capture story is not without its own serious complications. To lose enough energy to be captured and not just flung away again, an object typically needs to pass through a planet's extended atmosphere or interact with other moons. Neptune's largest moon, Triton, which orbits in the wrong direction, is also a suspected captured Kuiper Belt object, suggesting a dramatic history of celestial billiards. Could the two captures be related? Perhaps the gravitational chaos that allowed Neptune to ensnare the massive Triton is the same event that sent Nereid careening into its bizarre, stretched orbit, a single catastrophic period that completely reshaped the entire system. The problem is that Nereid's specific path is difficult to explain with a single, clean capture event. Its orbit is not just eccentric, it is also inclined, tilted relative to Neptune's equator. Some scientists propose that Nereid could be a leftover piece of a much larger collision, a fragment of a primordial Neptunian moon that was shattered by an impact, its debris then perturbed by Triton's arrival. This would make Nereid not a captured alien, but a native survivor of a system-wide cataclysm. The truth is, we simply do not have enough data. Our best views of Nereid are still the grainy images from Voyager 2 in 1989, which revealed a dark, irregular world but gave no hints to its composition. Without knowing what Nereid is made of, we cannot be sure of its origins. Is its surface the primordial ice of the Kuiper Belt, or is it the processed rock and ice of a moon that formed near Neptune? This tiny, distant moon, with its impossibly long year and frantic journey, is a single clue to a lost chapter in our solar system's history, a time when the giant planets may have migrated, scattering worlds and capturing others in a celestial rearrangement whose echoes we are only just beginning to hear. Deep within the asteroid belt, a dwarf planet gleams with alien light. The Dawn spacecraft, arriving at Ceres in 2015, revealed a world pockmarked with craters, but one feature stood out with impossible brilliance: a cluster of intensely bright spots at the bottom of the Oort crater. These were not subtle reflections, but dazzlingly white patches that shone like celestial beacons against the dark, carbon-rich landscape. The immediate mystery was profound. What material could be so reflective, so starkly different from the rest of this primitive world? The answer, when it came, was both definitive and deeply puzzling. Spectrometers on the Dawn probe identified the substance as sodium carbonate, a kind of salt you might find in a household laundry detergent or on a dried-up lake bed on Earth. But this was not a simple dusting. These were vast, concentrated deposits, forming a bright crust over the crater floor. The presence of the salt solved one mystery only to create a much larger one. How did enormous quantities of these specific salts end up so spectacularly concentrated on the surface? Salts like this do not just appear. They are the residue left behind when briny water evaporates. The leading hypothesis paints a dramatic picture of a hidden, briny ocean deep beneath the crust of Ceres. This is not a relic of the ancient past, but a body of water that may still exist today, insulated by a layer of ice. The Oort crater itself is the key to the story. The colossal impact that carved out this basin billions of years ago did not just dig a hole. It fractured the dwarf planet's crust, creating deep faults and weaknesses that reached down toward that hidden reservoir. This set the stage for a form of cold volcanism. In a process called cryovolcanism, the pressure from below, or the residual heat from the impact itself, could have forced that salty, liquid sludge upward through the fractures. When this supersaturated brine reached the airless, low-pressure vacuum at the surface, it would have instantly frozen and boiled simultaneously, a violent process known as sublimation. The water vapor would have escaped into space, leaving behind a brilliant, salty stain, a ghostly outline of the subsurface liquid that created it. The most astonishing part of this theory is the timeline. The bright spots are not ancient. They are remarkably fresh, with some estimates suggesting the most recent deposits could be just a few million years old, a mere blink in cosmic time. This implies that Ceres is not a dead world, but a geologically active one, with a subsurface that may still be churning and occasionally venting its briny contents into the void. The bright spots of Ceres are therefore more than just a curious geological formation. They are a window into a potentially habitable environment, where there is liquid water, salts, and energy, the fundamental ingredients for life as we know it are present. This tiny world, once considered just a large asteroid, may hold within its icy shell the same tantalizing possibilities as the ocean moons of the giant planets, a hidden sea silently signaling its existence with a gleaming, salty fingerprint. This sideways world spins with its poles pointing almost directly at the sun. Uranus is the solar system's great oddball, a planet that rolls around the sun on its side with an axial tilt of 98 degrees. This means its poles experience 42 years of continuous sunlight, followed by 42 years of utter darkness, seasons of an extremity we can barely comprehend. The most compelling explanation for this bizarre orientation is as dramatic as it sounds: a colossal impact. The theory suggests that in the chaotic early days of the solar system, a protoplanet, at least twice the mass of Earth, slammed directly into a young, still-forming Uranus. The titanic force of this collision is thought to have literally knocked the entire world over, reorienting its spin axis by 90 degrees and leaving it in its current sideways state. This single catastrophic event could explain the planet's unique rotation in one fell swoop. Yet, the giant impact theory, for all its satisfying violence, runs into two major complications that challenge its simplicity. The first problem is with the moons. All 27 of Uranus's known moons orbit perfectly in the planet's equatorial plane, meaning they also circle the Sun sideways, tracing their paths around the planet's waist as it rolls along its orbit. If a single gargantuan impact knocked Uranus over, its moon system should have been utterly devastated, shattered into a new, randomly oriented ring of debris. The fact that the moons share the planet's extreme tilt suggests they formed from a disk of material that settled after the Great Tilting Event. This implies the impact happened very early, while Uranus was still surrounded by the cloud of gas and dust from which its moons would later coalesce, a timeline that is possible but incredibly precise. The second, even stranger complication comes from the planet's magnetic field. Unlike Earth's relatively neat magnetic field, which emerges from near the geographic poles, the magnetic field of Uranus is a tangled mess. It is both severely offset, meaning its magnetic north pole is not at its geographic north pole, and dramatically skewed, tilted by a staggering 60 degrees from the planet's already extreme spin axis. This suggests that the magnetic field is not being generated deep in a well-ordered, rotating core like Earth's, but is instead created in an intermediate, slushy layer of electrically conductive water and ammonia. A giant impact could have scrambled the planet's internal structure, disrupting the flow of material that generates its magnetic field and leaving this permanent, lopsided signature. So we are left with a puzzle, a world knocked on its side by a force of unimaginable violence, yet accompanied by moons that tell a story of a calm aftermath and haunted by a magnetic ghost that points in all the wrong directions. The story of Uranus is a reminder that even the most elegant cosmic explanations often leave behind a trail of confounding, beautiful details. That same faint young sun hides a layer of blistering, paradoxical fire. Just above its brilliant yellow surface, a region we call the photosphere, the temperature is a toasty 6,000 degrees Celsius. This is the sun as we see it, the source of all light and warmth for our solar system. But if you rise higher into the wispy, pearly outer atmosphere known as the corona, the temperature does something that seems to defy the very laws of physics. Instead of cooling down, it soars, skyrocketing to over 1 million degrees. This is the solar corona heating problem, a riddle that has baffled physicists for generations. It is as if you walked away from a campfire, and with each step, the air grew exponentially hotter, a phenomenon that directly contravenes our basic understanding of thermodynamics, where heat flows from hotter areas to cooler ones. So what incredible engine is pumping energy directly into this tenuous, far-flung atmosphere? Scientists have two primary suspects, and the hunt for the culprit is a tale of competing ideas and missing evidence. The first theory points to countless tiny explosions. The sun's magnetic field is a tangled, dynamic web, constantly twisting and snapping. Each time these field lines break and reconnect, they can release a minuscule burst of energy called a nanoflare. Individually, each nanoflare is far too weak for our telescopes to detect. But if they are happening constantly, billions of them every second all across the sun, Their collective energy could be enough to cook the corona to its incredible temperatures. Think of it like a vast field of popcorn, where no single kernel makes much sound, but the collective pop and sizzle creates a roar of heat. The second major theory focuses on powerful magnetic waves. The sun's surface is a churning, convective cauldron, and this motion sends powerful vibrations racing up through the magnetic field lines that arc into the corona. These are not sound waves, but magnetohydrodynamic waves, essentially ripples of pure magnetic energy. As these waves travel upward and enter the much less dense corona, their energy becomes concentrated, and they can crash and dissipate like ocean waves on a shore, dumping all of their ferocious heat into the thin atmospheric gas. Imagine shaking one end of a rope, sending a wave down its length, only for that wave to transform into a blast of heat when it reaches the other end. For decades, the debate has raged. Is it the staccato fury of invisible nanoflares, or the constant, rhythmic pounding of magnetic waves? The frustrating truth is that our most advanced solar observatories have found evidence for both. We can see some waves, and we can infer some small, explosive events. Yet when we add up all the energy we can actually measure from these processes, we still come up short. There is a massive energy deficit, a gap in our accounting that suggests we are either missing a key type of wave, or a whole population of even smaller, more frequent nanoflares, or perhaps an entirely different mechanism we have not yet conceived. The corona's searing heat remains an open case, a testament to the fact that even our own star, the very heart of our system, holds fundamental secrets about how the universe operates. The hunt for a hidden giant begins not with a telescope's gaze, but with the strange, clustered paths of distant ice worlds, far beyond Neptune, in the frigid expanse of the Kuiper Belt. A handful of small objects are not scattered randomly. Instead, their elongated orbits are mysteriously aligned, as if an unseen shepherd is herding them, keeping their farthest points in space grouped together. This peculiar orbital clustering is the primary clue fueling the most dramatic astronomical hypothesis of our time, the existence of a ninth planet. This is not a small, rocky body, but a potential super-Earth, a world with up to 10 times the mass of our own, tracing a vast, lazy orbit so far from the Sun that a single year there could last 20,000 Earth years. The gravitational pull of such a hidden colossus would be the simplest explanation for shepherding these distant objects into their strange, synchronized dance. It is a compelling story, a ghost story written in the language of gravity and orbital mechanics. Yet, the search for this phantom world has proven incredibly difficult. Its proposed orbit is so immense that the planet, if it exists, would reflect only the faintest whisper of sunlight, and we have only surveyed a tiny fraction of the sky where it could be hiding. Astronomers are meticulously scanning the deepest, darkest voids, looking for one slow-moving pixel of light against a backdrop of fixed stars. But what if the ghost is not there? A compelling alternative suggests that there is no single massive planet, but rather the collective gravity of all the smaller, unseen objects in the Kuiper Belt itself. If the distant solar system is more crowded than we think, the combined gentle tug of thousands of small, icy bodies could, in theory, mimic the gravitational influence of one large one, creating the illusion of a shepherd without the need for a super-Earth. This idea of a collective gravitational effect challenges the very need for a Planet 9, proposing that we are seeing not the hand of a giant, but the whisper of a crowd. The resolution of this mystery is about far more than just ticking a box on a planetary checklist. Finding or definitively disproving Planet 9 is crucial to understanding the final architecture of our solar system. Its existence would rewrite the story of our cosmic neighborhood's formation, suggesting a dramatic past where planets were scattered and rearranged. Its absence, however, would be equally profound, forcing us to accept that the subtle patterns we see in the darkness are driven by a chorus of tiny, unseen voices, a reminder that the universe often conceals its truths in the sum of many small parts, rather than in a single grand design. Neptune's captured moon Triton performs a cryovolcanic spectacle unlike any other. When Voyager 2 flew past in 1989, it saw dark, dusty plumes rising straight up from the icy surface, reaching heights of 8 kilometers into a thin, hazy atmosphere before being swept away by the wind into long, dark streaks across the nitrogen snow. These are not water geysers like on Enceladus, but something far more exotic, eruptions of vaporized nitrogen gas, mixed with sooty, dark dust. The driving force behind these eruptions is a bizarre and clever process unique to this world, a solid-state greenhouse effect. Imagine a sheet of clear, solid nitrogen ice acting like a pane of glass. Sunlight, even the feeble sunlight at the distance of Neptune, passes directly through this transparent ice. It does not heat the ice itself, but instead strikes a darker, more absorbent layer of material just beneath the surface, perhaps complex organic compounds or rocky dust. This dark substrate heats up, just like the interior of a car on a sunny day. But instead of warming the air, this trapped heat does something remarkable. It vaporizes the solid nitrogen ice at the boundary between the dark layer and the transparent ice sheet above. The nitrogen does not melt into a liquid, it sublimates, turning directly from a solid into a high-pressure gas. Trapped beneath the heavy, solid ice ceiling, this gas builds up immense pressure until it finally finds a weak point, a fissure or a crack, and then it explodes upward, ripping through the icy crust and blasting a fountain of nitrogen gas and entrained dark dust high into the sky. This entire cycle is a perfect, self-contained engine, powered by nothing more than distant sunlight. It is a form of cold, alien weather happening on a geologic scale. The plumes themselves are transient, some active during the Voyager flyby and others dormant, their activity dictated by the subtle changes in Triton's extreme seasons as it orbits Neptune. This strange process raises a profound question about the Moon's internal structure. The solid-state greenhouse effect explains the how, but what provides the endless supply of dark dust that gets blasted into those dark streaks? Some scientists speculate that there might be a complex chemistry happening deep within Triton, perhaps even a hidden, slushy ocean that slowly churns and brings dark material to the surface over time. The geysers of Triton are a stunning demonstration of how even in the coldest reaches of our solar system, simple physics can conspire to create dynamic, eruptive beauty. Our own moon holds another secret written in light and shadow. Scattered across its grey plains are bizarre, cloud-like patterns known as lunar swirls. These are not craters or mountains, but bright, swirling markings that look as if a giant finger painted swirling, brilliant designs across the lunar dust. The most famous Rheanur Gamma is a beautiful, tadpole-shaped curl of dazzling white, stretching for hundreds of kilometers across the ocean of storms. The strangest part is that these bright swirls lie perfectly flat. They are purely a color variation on the surface, completely unconnected to any hills or valleys below. Their beauty hides a deep magnetic mystery. Each one of these bright swirls is perfectly matched by a powerful, localized magnetic field, a miniature magnetic bubble embedded in the lunar crust. These magnetic anomalies are the key to the swirl's existence. The moon has no global magnetic field to protect it, so the solar wind, a constant stream of charged particles from the sun, constantly bombards the surface. This relentless radiation slowly darkens the lunar soil over time in a process called space weathering. But over these magnetic bubbles, something remarkable happens. The magnetic field acts as a miniature shield, deflecting the solar wind and protecting the soil beneath it from this darkening effect. The protected areas remain bright and reflective, while the surrounding soil slowly turns a darker gray, painting the swirling pattern into existence. The central puzzle is where these protective magnetic bubbles came from in the first place. How does a world with no planetary magnetic field generate such intense, localized magnetism? One dramatic theory points to a violent celestial arrival, perhaps a comet, rich in iron and other magnetic materials, slammed into the moon in the distant past. The incredible heat and pressure of the impact could have vaporized the comet and magnetized the underlying lunar rock, imprinting a permanent magnetic scar in the shape of the impact plume. This would forever after protect that one patch of ground, creating a swirl like Rayner gamma. A competing theory looks inward to a more dynamic lunar past. Billions of years ago, the moon's interior was likely molten and churning. It may have had its own global magnetic field, generated by a dynamo in its core, much like Earth has today. As this lunar dynamo slowly died, the last remnants of its magnetic field could have become frozen into certain types of surface rock, creating a patchwork of magnetic fossils that we see today as the swirl's sources. This would mean the bright patterns are the ghostly footprints of the moon's own fiery, magnetic heart. Yet both theories face challenges. A comet impact seems almost too perfectly artistic to create such elegant, swirling shapes. And the ancient dynamo theory struggles to explain why the magnetism is so intensely concentrated in these specific, beautiful patterns and not more randomly scattered. The lunar swirls are thus a double enigma. We see the effect of their magnetic protection, but the origin of the shield itself remains locked in the moon's silent history. They are a reminder that even a world we have walked upon can hold on to profound secrets, its most brilliant artwork created by an invisible, protective hand. Floating between Mars and Jupiter lies a relic of cosmic violence, an asteroid named 16 Psyche. This is not a typical rocky body, but a world made almost entirely of metal, a colossal nugget of iron and nickel, over 200 kilometers wide. Scientists believe it is the stripped bare, exposed core of a failed planet, a world that was shattered in the solar system's violent youth before it could fully form. Its metallic nature alone makes it a treasure trove, but the real mystery lies in its apparent lightness. When astronomers measured its mass and volume, they found its density to be surprisingly low for a solid lump of iron and nickel. If it were a pure metal core, it should feel far heavier. This discrepancy has spawned a fascinating puzzle. What is the true nature of this metallic world? It cannot be a solid sphere of iron. One compelling theory suggests that Psyche is not a dense ingot, but a cosmic sponge. The asteroid may be incredibly porous, riddled with vast caverns and empty spaces that make up as much as 50% of its volume. This could be the result of a catastrophic impact that blew away its rocky mantle, but left the metal core shattered and loosely reassembled, a pile of metallic rubble held together by its own weak gravity. Another possibility is that its composition is not as pure as we think. Perhaps Psyche is a mix of metal and lighter rock, a sort of cosmic brindlestone that never fully separated into a distinct core and mantle. The most tantalizing idea is that we are seeing the result of a unique form of metal volcanism. In the extreme heat following its formation, Psyche's surface might have erupted with liquid iron, creating strange metallic lava flows that cooled into a less dense, frothy crust. To solve this, we must go there. NASA's Psyche mission is now journeying to this metal world, carrying instruments designed to map its composition and structure. By measuring its gravitational field with exquisite precision, the spacecraft will determine if the asteroid is solid or porous. Its spectrometers will analyze the surface, revealing the exact mix of metals and rock. This is more than just a visit to a strange asteroid. It is a journey back in time, a chance to look directly into the heart of a planet that never was. The answer will rewrite our understanding of how planets are built and destroyed, revealing whether this metallic ghost is a solid monument to a lost world, or a fragile, hollow shell telling a far more complex story. Our map of the cosmos may have an unseen territory, a region of unimaginable mass exerting its pull from beyond the edge of everything we can see. This is the mind-bending mystery of the dark flow, a controversial observation that some galaxy clusters are streaming through space on a coordinated rush, as if being drawn by a cosmic magnet located outside our observable universe. The story begins with the cosmic microwave background, the faint afterglow of the Big Bang that fills all of space. This ancient light is the most perfect reference frame we have, the backdrop against which all other motion can be measured. When scientists meticulously mapped the motion of enormous clusters of galaxies, they expected to see a random, turbulent drift, the result of all the known gravitational tugs from neighboring superclusters. Instead, they found a startling pattern. A vast swath of galaxy clusters, stretching across billions of light years, appeared to be moving in a coherent stream at velocities of over 3 million kilometers per hour, all in the same direction. This motion cannot be explained by the gravitational pull of any known structure in our universe. It is as if these clusters are caught in a river whose source lies beyond the horizon of what we can observe. The most radical explanation is that the immense gravitational influence of something truly alien is causing this flow, a region of space-time with a staggering concentration of mass that lies outside our cosmic horizon. Since nothing from beyond that horizon can ever reach us, not even light, this suggests our universe is just one patch of a far vaster and more complex multiverse, and we are feeling the tidal pull of another universe entirely. Skeptics, however, argue this is a step too far. They propose the dark flow could be a colossal systematic error, a subtle artifact in how we interpret the cosmic microwave background data itself. Perhaps our understanding of this primordial light is incomplete, or unknown local effects are creating an illusion of motion. The debate is fierce because the stakes could not be higher. If the dark flow is real, It forces us to completely redraw our picture of cosmic structure, admitting that our entire observable universe is but a leaf floating on a much grander river. If it is an error, it reveals a critical flaw in our most fundamental cosmological tool. This mysterious current, whether a ghost from another reality or a flaw in our perception, reminds us that the ultimate boundaries of our knowledge are not walls, but veils, and behind them, the true nature of reality may be moving in ways we are only beginning to sense. From the silent, ghostly signal that screamed just once to the colossal hexagon spinning over Saturn, our journey through these 25 mysteries reveals a solar system brimming with secrets. We have wandered past worlds knocked on their sides, sniffed the tantalizing breath of potential life on Mars, and stared into the frozen eyes of ancient, crying moons. We have traced the gravitational whispers of unseen giants and felt the baffling heat of the sun's own corona. Each puzzle, from the faint young sun paradox to the dark flow of distant galaxies, stands as a testament to a simple, profound truth. Our cosmic backyard is anything but ordinary. It is a dynamic, chaotic, and deeply enigmatic neighborhood where every answered question seems to unlock 10 more. These phenomena are not mere curiosities. They are the very frontiers of our understanding, challenging our models and forcing us to rethink the fundamental laws of physics and the story of our own origins. The greatest discovery in all of this is the sheer scale of our own ignorance, a humbling and exhilarating realization that the universe is far stranger and more wonderful than we ever imagined. So we turn this final question over to you. With 25 cosmic riddles now laid bare, which one captivates your imagination the most? Was it the violent tilt of Uranus, the shimmering plumes of Enceladus, or the silent, waiting metal of asteroid Psyche? Share your favorite mystery in the comments below, and never stop looking up, for the next great discovery is always hiding in plain sight, just waiting for a curious mind to find